Welcome to the third Science Gem from HorvickResearch.com. In this third Science Gem, I will cover how you can talk about scientific studies in an appropriate manner. There is no need to sensationalize research findings, as this would just make us look like we don't understand how science works. A good framework to use when you want to tell someone about an individual research study is to remember to share 4 things. You first need to tell them what the researchers did. Ideally start by telling them who published the study, where they published the study, and then tell them what they actually did in their research study. Then tell them what they found, what the results of the study were. Next, it's a good idea to highlight the strengths of the study and translate it for your patient by pointing out what it could mean to them personally. Relate it to their health situation if you can. And this is a really good time also to tie in surrounding research studies that are relevant to this particular study you're talking about. This will give that particular study's findings context. But it's equally important to remember this last step and also point out with all research methods there are limitations, and then highlight the actual limitations of this particular study that you're telling them about. If you follow this framework, you will be sharing good, sound knowledge with your patient in an evidence-informed manner. You don't need to sensationalize the research findings, and you are in fact empowering your patient to make good health choices for themselves and their family. And remember, it's up to them, whatever that choice might be. There's no need to judge them for their choices, even if their choice is not aligned with your own. So let's take a closer look at how you can put this into action by talking about individual studies. In this first example, it's a study that was conducted by Bernadette Murphy and Paul Marshall at the University of Auckland, and it was published in JMPT, the Journal of Manipulative and Physiological Therapeutics, in 2006. It's a really cool study that was looking at their subjects' ability to feed forward activate their core abdominal muscles when lifting up an arm as fast as they could when cued on a computer. So the subjects were asked to stand upright and watch a computer screen as shown in image A. Then, when the computer cued them to lift either their left or their right arm as fast as they could, they would lift their arm up to 90 degrees out in front of them. So if the cue came for the right arm, they would lift their arm up as fast as they could to 90 degrees straight out in front of them. Now, in an ideal situation, your brain will first switch on your core abdominal muscles before it will tell your shoulder muscle to move. This stabilizes your body so that you don't fall backwards, and it protects your spine. So Bernadette and Paul could measure precisely from these EMG electrodes over the anterior deltoid muscle and over the deep core abdominal muscles exactly when their subject's shoulder muscles switched on in relation to their core abdominal muscles switching on. Now, they tested 90 healthy asymptomatic young males, and they found that 17 of these 90 young, healthy, asymptomatic males were not, in fact, able to pre-activate their core abdominal muscles. Their brains would first send messages to their shoulder muscles, and then, like a reaction, they would activate their abdominal muscles. This is not good for the spine. 6 months later, they retested 13 of these 17 individuals that could not pre-activate their core abdominal muscles. And what they found was that they still couldn't pre-activate their abdominal muscles. This is really interesting because it means that 6 months of daily living does not alter this key important aspect of the central nervous system function. 6 months of active daily living does not itself improve their ability to stabilize their core when they lift an arm up. So then Bernadette adjusts the 13 healthy young men. She adjusted their sacroiliac joints and found that a single adjustment improved their ability to feed forward activate their core abdominal muscles by almost 40%. And for some of the subjects, there was actually a complete reversal so that their core abdominal muscles were switching on before their shoulder muscles showed any detectable EMG activity. This is really remarkable because it means that a single sacroiliac adjustment can for some individuals completely reverse an unhealthy reactive activation pattern to a protective feed-forward activation pattern, and this is amazing. There are limitations with this study, as there is with all studies. For example, in the study they only had male subjects, so if your patient was a woman, the patient that you wanted to talk about this research with, you would need to point out that that's a limitation, that the study was only done in men. We assume, of course, that the physiology works the same way in women, but we don't know that for a fact. Another limitation with this study is that we don't know how long these findings last. There was only one pre- and post-recording that was conducted, so we don't know if this lasts more than half an hour or an hour. We really don't know. We are currently conducting studies at the Centre for Chiropractic Research where we're following up on this to see how long it lasts and also to verify that the same findings happen in women as well as men. So let's take this step by step. In this example, if you were to talk about it and you were to follow the framework that we discussed earlier, these are the things that you could say to a patient. So first of all, you want to tell them about what was done. So you mentioned that a study by Marshall and Murphy in 2006 that was published in JMPT, where they conducted a study where they looked at 90 healthy young asymptomatic males. And they screened them to see how many of them could actually feed-forward activate their abdominal muscles. You'd have to explain to your patient what that means and why it is a protective thing that your brain will first switch on your core abdominal muscles when lifting an arm up. And then you would tell them that what they did, they assessed for how many of these 90 healthy asymptomatic young males actually were able to feed for their abdominal muscles. Then you would describe the results, so what they actually found. Now 17 out of those 90 healthy asymptomatic young males did not fit the criteria for feed-forward activation. They were in fact switching their shoulder muscle on first before their core abdominal muscles would switch on. Now 13 of the 17 were available to be remeasured 6 months later, and the findings correlated remarkably well in these 13 when they were first recorded 6 months earlier to the second recording. So this means that 6 months of daily living does not change this measure. And then they found that there was a significant improvement of almost 40% in the ability to feed-forward activate the core abdominal muscles in the group that got adjusted. Next, it's good to describe the strengths of the study and also why it might be relevant to your patient in practice. So for example, one of the strengths is that they actually waited the full 6 months before they retested the group, because this means that 6 months of daily living is not enough to switch on this protective feed-forward central nervous system function. So the study findings are relevant to healthy young males in your practice. Even if they don't have any symptoms, they may actually be at risk of developing low back injuries. This is because we know a different study done by Kolowicki et al. In 2005 that showed that if they could not activate their core muscles properly, they are at greater risk of developing low back injuries. So that's why this study is particularly interesting to your patients, because you, with one single adjustment, are likely to switch on this protective mechanism that 6 months of daily living does not. Then it's a good idea to mention limitations of this study. Particularly if your patient is a woman, you can point out that this study was actually only conducted in males, and that we assume therefore that it would also work for females, but that we don't know that yet. You could point out, if you like, that researchers are currently studying this in women. Another limitation that you can mention to your patients is that we don't know how long it lasts. So you might have this protective effect. It might last half an hour, might last 24 hours, might last a month. We don't know this yet. Again, you can point out that this research is currently being conducted. Right, let's look at another study. This is a study that I conducted with Bernadette Murphy in my research laboratory at the New Zealand College of Chiropractic. It won a poster award at the World Federation of Chiropractic Congress in 2009 and became an award-winning paper at the Association of Chiropractic Colleges Research Agenda Conference in 2010. It's published in JMPT in 2011. It was also funded by Australian Spinal Research Foundation. What we wanted to know was whether people who were developing neck pain problems were less able to accurately perceive where their upper limb was in space, and whether adjusting subluxations for them could improve this. So we examined 25 people who fit the criteria for subclinical neck pain, and compared them with 18 completely healthy people that have never ever had any pain or accident with their necks ever. So remember, the subclinical people is a group where they have ongoing, reoccurring pain, tenderness, stiffness or ache in their neck. This particular one was for neck patients. But they don't always have this pain, and on the day that they were studied, they had absolutely no pain. So we're comparing these people that are developing problems with people that are completely healthy and have never had any pain or ache or stiffness or tension or accidents with their necks ever. All our subjects were lying on a low-friction whiteboard with their right arm out to the side so that we could move their arm up a little bit or down a little bit. We would then bring them back to the rest position and then ask them to put their arms back in that target position that we'd placed their arm. Their eyes were closed, and we could measure this very accurately because they were connected up to an electrogoniometer. There were also cloth donuts underneath their elbows and wrists so that their arm was not touching the actual whiteboard itself, so that they could get no additional cues from their skin rubbing against the board. What we found was that at baseline, the totally healthy group was significantly better at reproducing the elbow target angle. And when we adjusted the subclinical neck pain group, their absolute error significantly improved. All I adjusted was their necks because we didn't want to move the position of our subjects or change their body in any way. So they were taped down to this whiteboard and I just adjusted the subluxations that I found in their necks. The interesting thing was that we discovered that both groups complained that they were getting tingling and numbness down their arms when they were lying the way they were. For the control group participants, their elbow joint position sense accuracy was actually significantly worse after the control intervention. So just lying there, having your arm in this position and being tested was likely causing a bit of thoracic outlet syndrome and worsening their ability to accurately sense where their arm was. So it's pretty amazing that when I adjusted these subjects, that they had an improvement in their accuracy of knowing where their arm was, even though they also complained that their arms were going numb and tingly. So if you were going to give this one a go and follow the framework like we talked about before, here are the 4 things that you would talk about with a patient. First of all, you start with what they did and describe their methodology. So you'd point out that this was a study done by Horvig and Murphy and back in 2011 published in JMPT, and that we had 25 subjects with subclinical neck pain and 18 healthy control participants. And it'd be a good idea to point out what that means. And that they took part in a pre- and post-experimental study. So what we did to begin with is compare the healthy people that were developing neck pain. And then what we did is we adjusted the people that were developing neck pain, where they were subluxated, while their healthy control group just waited for 5 minutes. We used an electrogoniometer so we could very accurately determine exactly where their arms were in space, and we used this to measure their ability to know precisely where their arm was. So then you go on and describe the results of the study. Well, what we found was that at baseline, the control, the healthy group, was significantly better at reproducing their arm compared to the people that were developing low-level neck pain. Now this is kind of key because it sort of suggests that if you are developing problems in your spine, that you are less aware of where your body is in space. And what was also interesting is after a single session of just adjusting subluxations in the neck, these people that were developing problems were better able to reposition their arm. Not as good as the complete healthy group, but there was definitely a significant improvement. It's also a good idea to point out that the control group's participants' joint position sense accuracy got worse after the control intervention because of the setup, so that they were actually seemed to be getting a little bit of tingling and numbness down their arm. And so it's almost remarkable in that case then, when we adjusted subluxations, that there was an improvement. The next thing you'd want to describe is how this could be relevant to a patient in your practice. So for example, it could mean that if your patient was being a bit clumsy, like stubbing their toe often or knocking their elbows on door frames, that adjusting their spine might actually help improve their proprioceptive accuracy. That adjusting subluxations makes it easier for your brain to know where your arms and legs are in space. We have also shown the same thing in an elderly population over several months of chiropractic care, that we can improve the ankle joint accuracy as well. So not just arms but also legs, and we know that with scientific studies. And then finally wrap it up by mentioning the limitations of the study. For example, you could point out that this study was conducted in young, healthy students, and that if you have an elderly patient, that we don't know for sure that it improves their elbow joint position sense, but again you could mention that the study that was done in the elderly showed improvements in ankle joint position sense, and that we assume that the physiology is pretty much the same. Another limitation that you can point out is that again we don't really know how long these things last. We do know that in the elbow joint position sense with a single session that at least it lasted for 20 minutes, but you could also highlight that the study conducted in the elderly individuals with showing improvements in the ankle joint position sense, this was recorded several days after they'd had 12 weeks of chiropractic care, and it was still significantly improved. Here are some of the key references for the papers that we have covered in this review. These studies are the first studies that are explained to patients in the animation sent out to them from chiropracticreality.com. So hopefully by now you feel more confident if one of your patients comes and wants to ask you about any of these studies. And just remember the framework. There are 4 things that you want to talk about: what they did, what they found, what it might mean to your patient, and then mention the limitations as well. In wrapping up, I'd like to take this opportunity again to invite you to join us at the forefront of chiropractic research by joining the Centre for Chiropractic Supporters Program. And I really hope that you found this video useful, and I look forward to hearing from you with any feedback on how we can make these videos even better for you.